Building your own AI from scratch can be an exciting and rewarding project. The first step is to define your project goals clearly. What problem are you aiming to solve with AI? Whether it's developing a chatbot, a recommendation system, or an image recognition model, having a clear objective will guide your entire development process. Start by outlining the specific task your AI will perform and identify the type of data it will need to learn from. It's also important to consider the scope of your project. Is this a small prototype, or are you building something that needs to scale for many users? Answering these questions up front will help you make more informed decisions throughout the process. Data is the backbone of any AI project. The performance of your AI depends largely on the quality and quantity of data it learns from. Start by identifying the type of data required. This could be images, text, audio, or structured data such as databases or spreadsheets. Gathering high-quality data from reliable sources is crucial. For example, if you're working on an image recognition project, datasets like ImageNet or Safari 10 are excellent starting points. You might also need to collect your own data, which can involve web scraping, using APIs, or even manual data entry. Remember, the more diverse and representative your data, the better your AI will perform in real-world scenarios. Always keep in mind data privacy and ethical guidelines, especially when handling sensitive information. Understanding these nuances early on will set a solid foundation for your AI project. Choosing the right tools and setting up your development environment are critical steps in your AI project. Python is the most popular programming language for AI development due to its simplicity and extensive ecosystem of libraries like TensorFlow, PyTorch, and Scikit-learn. These libraries offer pre-built models and functions that make it easier to handle complex tasks, saving you time and effort. Depending on your project, you may also consider using other languages like R for statistical analysis or JavaScript for AI and web applications. Set up your coding environment using tools like Jupyter Notebook for interactive coding or Visual Studio Code for a more versatile development experience. Make sure your environment is configured with the necessary libraries installed, and keep your workspace organized with clear naming conventions for files and scripts. This will make your development process smoother and help you stay on track as your project evolves. With your project goals defined, data gathered, and environment set up, you're ready to start building your AI. Careful planning and preparation are the keys to a successful AI project. As you move forward, remember to be flexible and open to adjusting your approach based on what you learn along the way. AI development is an iterative process, and the insights you gain from one phase will often inform and improve the others. Keep going, and you'll be creating powerful AI applications in no time. Now that your AI project is planned and prepared, the next step is data pre-processing, which is crucial for building a high-performing AI model. Data pre-processing involves cleaning, organizing, and transforming your data into a suitable format for training your AI. Properly pre-processed data can significantly improve your model's performance, while poorly pre-processed data can lead to inaccurate results, even with the best algorithms. Data pre-processing might include various steps depending on the type of data you're working with, but the overarching goal is to ensure that your data is as clean and usable as possible. Think of this stage as laying the foundation. Without a solid base, your AI model won't be able to perform effectively. Data cleaning is the first step in pre-processing and involves removing duplicates, handling missing values, and correcting inconsistencies. For numerical data, normalization may be necessary to scale values within a consistent range, which can improve the stability and performance of your model. For example, scaling all features between 0 and 1 or standardizing them to have a mean of 0 and a standard deviation of 1 can make your data easier to work with. If you're working with text data, tokenization is key. This means breaking down sentences into individual words or phrases and possibly removing stop words, which are common words that don't add much meaning. Feature extraction is another critical step where you identify and isolate the most relevant aspects of your data. This could involve using techniques like principal component analysis, PCA, to reduce the dimensionality of your data or employing feature selection algorithms to focus on the most predictive elements. After pre-processing, it's time to split your data into 3 sets: training, validation, and test sets. The training set is used to teach your model, the validation set helps fine-tune its parameters, and the test set evaluates its performance on new, unseen data. This division ensures that your model is tested rigorously and can generalize well to new inputs. Choosing the right model depends on the nature of your task. For image recognition, convolutional neural networks, CNNs, are typically the go-to choice due to their ability to process visual information effectively. For tasks involving sequential data, like language translation, recurrent neural networks, RNNs, or newer models like transformers are highly effective. Start with simpler models to establish a baseline performance. Then experiment with more complex architectures as your understanding deepens and your project evolves. Use cross-validation techniques to maximize the use of your data and refine your model selection process. With your data pre-processed and your model selected, you're ready to move on to training your AI. Training is where your AI learns to perform its task, and we'll focus on that in the next step. Keep refining your approach, and remember that building AI is an iterative process. Don't hesitate to revisit earlier steps if needed to achieve the best results. As you continue, each phase builds on the last, bringing you closer to a fully functional AI system that meets your project goals. With your data ready and your model selected, it's time to train your AI. Training involves feeding your model with the training dataset and allowing it to learn the patterns and relationships within the data. This process can take anywhere from minutes to hours, depending on the complexity of your model and the size of your dataset. During training, it's important to monitor metrics like accuracy, loss, and possibly more specific metrics like precision, recall, or F1 score, depending on your task. These metrics give you insights into how well your model is performing and where it might be struggling. If it's not performing as expected, adjustments to the model architecture, the learning rate, or other training parameters may be necessary. Remember to save checkpoints of your model's progress. This way, if something goes wrong, you can restart from the last good state without losing all of your work. Optimization and fine-tuning are crucial steps to enhance your model's performance. Hyperparameter tuning involves adjusting settings like learning rate, batch size, number of epochs, and the architecture of your neural network to find the best configuration. You can use automated tools like grid search or random search, or more advanced methods like Bayesian optimization to efficiently explore the hyperparameter space. Data augmentation is another powerful technique. By artificially expanding your dataset through methods like flipping, rotating, or adding noise, you can make your model more robust and less prone to overfitting. Consider using advanced optimization algorithms like ADAM, RMSprop, or SGD with Momentum, which can help your model converge faster and find better solutions. Regularization techniques like dropout, L1/L2 regularization, or batch normalization can also help in making your model more generalizable by preventing overfitting. Once your model is trained and optimized, the final step is deployment. Deployment involves integrating your AI into a real-world application, such as a web app, mobile app, or embedded system. Depending on your needs, you might deploy your model using platforms like Flask, FastAPI, or more robust environments like Docker and Kubernetes for scalable, production-ready deployments. If your model needs to handle real-time data, consider using tools like TensorFlow Serving or ONNX for optimized inference speeds. Post-deployment, monitoring your AI's performance is essential. Set up dashboards to track key metrics and implement alert systems to notify you if performance drops below acceptable levels. This allows you to address issues quickly, retrain your model with new data, or adjust the deployment settings as needed. Regular updates and maintenance are crucial for keeping your AI relevant and effective over time. Congratulations on building your AI from scratch. You've learned how to plan, pre-process data, train, optimize, and deploy your model. Building AI is an ongoing journey. Each project will teach you something new, and the skills you've gained here are just the beginning. Keep experimenting, learning, and refining your approach. If you found this guide helpful, don't forget to like, subscribe, and share your AI projects or questions in the comments. Your feedback helps us improve and create more content that meets your needs. Thanks for watching, and happy coding.